I am so excited to ask you some more personal questions.
Sure.
So winning the Nobel Prize in computing is such a profound recognition of your work. And it's really inspiring and energizing the whole community, especially the young students. And so I wonder if you can reflect for us on your journey from an AI and neuroscience student and expert to where you're making breakthroughs in a completely different discipline. Are there some moments that stand out?
You guys, before he answers that, please, no one talk. We really want to capture this, and we're recording it. 150 million people are going to see this soon, so we don't want your murmuring. Thank you.
Thanks. No, I mean, of course it was, I mean, there's many incredible moments on that journey, and also difficult moments that had to be overcome. As you mentioned, I started in computer science and then went into neuroscience, but all of that was in service of building general AI. That was the plan since I can remember. And then the whole point of that was that if you built that in the right way, it could be applied to almost any subject. And fortunately, I'm sort of infinitely curious, so I'm kind of a generalist, and I love delving into interesting new problems, no matter what domain it is. I've never really worried about domains or subject areas. I love interdisciplinary research, and actually DeepMind was originally set up to be very multidisciplinary. And so protein folding actually was something I came across as an undergrad. I had a lot of biologist friends who were obsessed with that problem. And it seemed like the perfect problem to what I call a root node problem. If you solve it, you unlock many, many other avenues of research. And it has a profound impact on a whole branch of research. And I also thought it was very tractable one day, even though we didn't have the techniques in the 90s for AI systems. Clear metrics, minimizing the free energy in the system, some training data. It felt like the right kind of jigsaw puzzle in a way that an AI one day could solve.
But was there a turning point, or was it kind of a background process that evolved? So was it a moment when you say, I'm going to do this?
Yeah, it was actually the AlphaGo moment that Yikan just mentioned. For us, it was a lighthouse moment. I think maybe for the whole industry that actually these new systems, these new learning systems, time had come. Right, that it solved a problem, an acknowledged problem, in this case Go, beating the world champion at Go, that had been tried since Deep Blue for 20 years. No one had made much progress and was maybe people thought was 20, 30 years further ahead. And we did it and showed the power of these new learning techniques, deep learning, reinforcement learning. And the moment sort of I got back from Seoul, the famous AlphaGo match with Lee Sedol, I decided that now was the time to start on the main track, if you like, of applying AI to big scientific challenges. And number one on my list was protein folding. I mean, there are many other things that I would love us to be able to do. Room temperature superconductors, solve one of the Millennium Prize problems. There's many and we're making good progress on many of these things. And there's incredible potential, I think. I think it's going to be a new golden era of scientific discovery over the next 10 years, helped by AI tools.
So going back to the magic wand of Max, if you were to have access to all the resources in the world and you were to pick one or two more problems with extraordinary impact, like AlphaGo, where interdisciplinary collaborations are really needed in order to make this kind of progress, what would you choose?
I would probably choose material science, I think, is a huge one. I feel like we've done some good work in that, I would say sort of AlphaFold 1 level. And I think we're nearing the big breakthroughs in that, where we can design all sorts of useful new materials to help from, you could imagine optimal batteries to new types of superconductors that would help with energy and climate and all sorts of things. You could also imagine new types of materials that help with capturing carbon and other things that we need. I think there's a lot of potential in material science. So that's one area. And I think also in energy in general, like fusion, coming up with new technologies where AI could be part of the solution. For example, we've used it to control plasma in a fusion reactor and try and stabilize it for longer.
Do you foresee a future where we have programmable matter, where we have where advances in material science allow us to program the physical matter around us,
Yeah.
like we program computers?
Yes, I think that will come maybe 5-10 years after AGI is the ability to kind of program, as you say, matter, atoms, both at the nanoscale, both chemistry, but also proteins themselves are kind of little bio-nanomachines. So you could imagine protein design, and we're working on this too in other labs as well, where you create new types of proteins that do new functions that natural proteins aren't able to do. And there's a whole discovery space of possible proteins, and evolution has only probably mapped out and explored a small subset of what is the universal possibility of proteins. And then you can imagine proteins and chemical matter together could be another interesting combination.
I'm just so excited about the future where we can also program mechanical properties like sound acoustic properties or elasticity. So these are
and you could imagine it being super useful for whether they're organic matter or chemical matter, things like you're saying, acoustic properties, these sort of new properties, but also you could have little nano machines, whether they're proteins or chemical, material, to go through your veins, unblock blockages, all these kinds of things in a very non-invasive, simple way.
Amazing.
I think that's the way for medicine is going to be.
So, as you think forward, 10 years out, what do you see as the most important problems for the AI scientific research community? What should we be working on?
Well, I think in terms of capabilities, reasoning and planning are big missing attributes, I think. This idea of how do we make our systems more inventive. So there's a lot there to explore on the capabilities front, tool use, long-term memory. But also, I think we need a lot of research on better benchmarks, not just for capability, but also what we were talking about earlier in the earlier panel about safety. So undesirable traits, maybe like deception, that we don't want our systems to have. And we need safety benchmarks that will alert us ahead of time that systems, even though they're getting more capable, they're also getting more risky, and then we can try to mitigate that. So I think there's a lot of work needed on benchmarking, and then I think there's a lot of research needed on understanding and interpreting what these systems do. There's a lot of promising work going on there, but I think there needs to be 10 times more work happening in that area.
Demis, we share this view of a future where machines and humans work together, and machines empower people with cognitive work. I also want physical work. So I wonder if you think about principles and frameworks that are really important and exciting to drive a positive partnership forward.
Yeah, well, look, I think the next era we're going to go through, maybe the next 10 years, is amazing combinations of human experts with incredible AI tools. I think about that mostly in science and in medicine, but I think you could also imagine it in robotics, and I'm sure that's what you're thinking about. And, I think there are many areas that are going to flourish now as we build these increasingly powerful AI systems as helpers and tools for what we do best, and free up us as scientists and experts, but also in everyday life to focus on the things that we like and that we do best.
It's a great vision for a future with AI.